The sun, the battery for all life on Earth, even when it's cloudy. Hi, I'm JD, and it's Earth Science Week, and we're celebrating it by exploring the sun's energy and the particles and waves that it sends our way. But before we get to that, let's find out what's happening at NASA now.
After completing its primary mission to map the infrared sky, NASA has extended the mission of its Wide Field Infrared Survey Explorer called WISE satellite. The spacecraft will now focus on our nearest neighbors, the asteroids and comets now in orbit around our Sun. Recently, WISE caught a glimpse of the comet Hartley 2, the target of an upcoming flyby mission in early November. Tune in next week for more information on this historic mission. Last week, a Soyuz spacecraft carrying 3 flight engineers from the United States and Russia lifted off from a launch pad in Kazakhstan to begin a 6-month tour aboard the International Space Station. The new crew members will join 3 other Expedition 25 team members who were already in orbit.
Now let's travel forward to the past.
Robert H. Goddard, noted American physicist and considered the father of modern rocket propulsion, was born this month in 1882. By 1926, Goddard had constructed and successfully tested the first rocket using liquid fuel. Since then, Goddard's basic design has been used to carry men to the moon, propel robotic spacecraft to the edge of our solar system, and launch the communications satellites that help connect us to people all over the planet. In fact, historians say that the first flight of Goddard's rocket was as significant to aviation as that of the Wright brothers' first flight at Kitty Hawk.
The electromagnetic, or EM spectrum, is a name that scientists give a bunch of types of radiation when they want to talk about them as a group. Using our eyes or an ordinary camera, we see a range of colors that we recognize as visible light. A special thermal camera will let us see gradients of heat radiating off of our bodies, as well as from everything else around us. And an infrared camera will let you see in the dark. Here to tell us more about the EM spectrum is Dr. Eric Brown de Colstoun, coordinator of Earth Science Education and Public Outreach at NASA's Goddard Space Flight Center. Eric?
My name is Eric Brown de Colstoun. I am a physical scientist here in the Earth Sciences Division in Goddard Space Flight Center in Greenbelt, Maryland. When people think about your hometown, I don't really have a hometown, so I started thinking, well, maybe my hometown is the planet. One of the things that people don't actually realize is that these waves are present virtually on a daily basis around us, and we don't necessarily think about electromagnetic energy as being part of our lives. The sun is the source of energy for a lot of processes on our planet. All the food that we have is a process that is driven by energy. The visible light from the sun comes down and is fixed by plants through the process of photosynthesis. People might not necessarily realize that, when you change the channel on your TV, that you're using electromagnetic energy to send a pulse to the TV to change the channel, or maybe when you heat your popcorn in the microwave, you're actually using microwave energy as well. We use then the electromagnetic spectrum in various ways. NASA has a fleet of satellites that orbit the Earth continuously, and they measure anything, from rainfall and hurricanes to the thickness of the ice sheets to sea surface temperature, land surface temperature, changes in the land due to land use. So We're measuring all of the different systems of the Earth at any one point in time. The big picture really is in terms of the heating of the planet that we're observing over the last, 30-some, 40-some years. As you know, fossil fuels, CO2 are greenhouse gases, so that means that they trap the heat of the planet. So that's a really good example of upsetting the normal balance, essentially. With remote sensing, we really see basically the change that we are bringing to our planet. It's sort of a cycle that we're trying to better understand, but that worries us, frankly. To me, my job is fun every day. I come in and I find something new, and I get to talk about things that I hadn't thought about before. And so it's a process of investigating. I mean, essentially, you're like, CSI for the planet.
Now let's set our sights even higher.
The next time you visit one of our great national parks, it's likely you'll see gigantic trees, mountain peaks and gorges, rare and colorful birds, bears, insects, and exotic plants. And now you'll also be able to have a unique view of the International Space Station. Recently, NASA joined with the National Park Service to provide the parks as environments free of light pollution that offer perfect vantages for spotting and tracking the Space Lab as it crosses the heavens. Don't forget, there's still time to enter the contests that we told you about last week. Deadline for the Earth Science Week Photography Contest is October 15th, and the last day for the Waitlist Challenge is November 1st. Check out these contests right here on the NASA Now homepage.
Well, that's it for NASA Now. Remember to tune in next week when we'll learn about NASA's efforts to search for life beyond our planet. We'll see you then on NASA Now.
NASA Now comes to you from the virtual campus at NASA Explorer Schools.